In this video, I'll do a couple more examples of using the properties of determinants to find determinants. So this is exercise E from exercises 1.6.2 in the notes. And we have x's down the diagonal and 1 everywhere else. Now this is a 3 by 3, so in theory you can just go straight for the formula, expand across the first row, and that should work out fine. But I'm just going to see if we can make it a bit easier using the properties of determinants, and also when we get our answer it should already be factorized. Now it's not obvious straight away how I can get a 0 row or column here, because there's no one move I can make, like before I took the first row away from the other two or something and get zeros. There's no obvious move here to do that. So what I'll do is I'll get 1 0 somewhere, and then I'll look again and see what I can do. So the most obvious one to me here would be to take the second row away from the third row and get a 0 down here. So that's what I'll do. So I'm going to say that row 3 minus row 2 is going to go in there to row 3. So I'm going to take the second row away from the third. So that's going to give me first and second row are staying the same. Okay, in this position now I have 1 minus 1 is 0. In this position I have 1 minus x. And here I have x minus 1. That's taking away the second row from the third one. Now let's look at what we have and see if we can make another 0. Now I want either a row or a column to be all zeros. So I want to either get one here or get one here. So looking at this, right, if I wanted to get one here, I'd basically have to take away this column from this one, but then I'd be getting this x minus 1 back in here to my 0. I don't want to do that. So I'm going to look at this position, and I think if I add together this column and this column, I'm going to get a 0 here. So I'm going to take the third column here and I'm going to add it on to the second one. Remember that this works for both rows or columns. If you add a multiple of a row to another row or a multiple of a column to another column, you don't change the determinant. So what I'll do here is I will take column 2 and add on column 3 to it. And that's going to be in here where column 2 is now. So let's work that out. So my first and third columns aren't changing. So x1 0, 1 1, x minus 1. And I'm going to add on the third column to the second here. So this is going to be 2. This is going to be x plus 1. And this is going to be 0. So that's 1 minus x plus x minus 1, 0. Now I can expand along the bottom row here to get my determinant. So it's going to be 0 times something plus 0 times something plus x times 1 times something. So if you remember your grid of signs, it went like this for your cofactors. So I'm down here, so it's going to be a plus. So we're going to have plus x minus 1 here times the determinant of this, because we're deleting that row and column. So that determinant equals x minus 1 times the determinant of x, 2, 1, x plus 1. So I could try and do some more row and column manipulations to make this a bit easier, but I think I'll just go straight for it with the formula. So that x minus 1 is going to stay as is, and the determinant of a 2 by 2 matrix is, well, this one. We have our x times x plus 1 minus 1 times 2. So I'll just figure this out. So that is x squared plus x minus 2. All I have to do now is factorize that quadratic. So let's do that. So it's going to be like x plus something and x plus something else. So they're going to add together to make minus, multiply together to make minus 2. So that's probably 2 and minus 1. So yeah, x plus 2 and x minus 1 should do it. So what I have here now is overall x minus 1 squared times x plus 2. And if I look at the answer, what I was asked to show actually was that it was equal to 1 minus x squared times x plus 2. Now, this is actually the same thing. So like, because of course x minus 1 is just minus 1 minus x, and we're squaring it anyway. So I'll just work that out in detail. So that's equal to, so x minus 1 is minus 1 times 1 minus x, right? And all that is squared. Of course, that's minus 1 squared times 1 minus x squared times x plus 2. And of course, minus 1 squared is just 1. So I'm left with just 1 minus x squared times x plus 2. And there you go. Now, before I leave this example, I want to go back to this step where we just after expanding along the bottom row. And instead of going straight for the formula here, I just want to show you another option. So what I could do is go to my row and column operations again. And what I'd like to do is get a 0 somewhere. And so there's no one move I can use to make a 0 in this matrix anywhere by adding rows or columns. But let's just have a look at what kind of things I could do as a first move. I could add on the first row to the second row. If I did that, I'd get x plus 1 in here, and I'd get x plus 3 here, so not that useful. What if I took the first row and I subtracted it from the second one? Well, then I would get 1 minus x down here, and I would get x plus 1 minus 2, x minus 1 in here. So that would be 1 minus x and x minus 1. So actually then I could make another move to get a 0, because that one is minus the other. So that seems like a good move. So to write that down, it would be row 2 minus row 1 going into where row 2 is now. So row 1 stays the same. Here I get 1 minus x, and here I get x plus 1 minus 2, x minus 1. So now if I add together my two columns, I'm going to get a 0. So what I'll do is I will say column 2 plus column 1 is going to go in there to, let's say, where column 2 is now. So I'm going to take the first column, add it onto the second. So this x minus 1 outside here stays as is. First column stays the same here, x, 1 minus x. And I'm going to add these together, so I'm going to get x plus 2 here, and I'm going to get 0 here. So now we're almost done. Now get the determinant of a 2 by 2 matrix. So in this case, it's equal to x times 0 minus 1 minus x times x plus 2. So here we go, x times 0 minus 1 minus x times x plus 2. Well, x times 0 is 0, obviously. And then minus 1 minus x is equal to x minus 1 times x plus 2. So what I've got here now is just x minus 1 squared times x plus 2. And of course the answer asks for 1 minus x squared, but we showed together on the last page that's the same thing. So that's the same as 1 minus x to be squared times x plus 2. So by doing some more row and column operations there, we kind of skip the factorization step. Now it doesn't matter very much for a 2 by 2, but actually we could have at the very beginning of this in the 3 by 3 gone to the formula, and we would have got some big long thing that we would have had to factorize afterward. And actually the advantage we got was a very similar one by doing the row and column operations, in that we already had one factor, this one, taken out next to our 2 by 2. But once you get down to a 2 by 2, really either way is fine, but for the 3 by 3 definitely the row and column operations would be the way to go here. So that's all of the examples in that section done out for you between this video and the other one. So there's just F there, so I'll leave that to you, and if you have trouble with it we might look at it in a tutorial.